learn now is the concept of theorem of total probability, which help us calculate the probability of an event using other events, which are uh, events, let's call them b1 to bn, and this is the formula. P of some event we want to calculate is the sum of intersections of this event with b1, b2 until bn. Now, the events b1 until bn should satisfy two things. One, they are mutually exclusive, namely, they cannot happen at the same time. Let's say if you draw a coin. So one side cannot happen, cannot when the other side happens, right? They are mutually exclusive. Also, they should cover all possible outcomes, namely, together B1 until Bn form the entire sample space. Okay, so for A, any probability event, the probability of A is like this, and this is the theorem of total probability. The probability of A is the sum of A intersection probability of A intersecting with B1 plus A intersecting B2 plus etc plus A probability of A intersecting with Bn. And this is the theorem of total probability. Now, it can also be written like this. This is more short writing of this. Now let's take an example. We have three groups of students. One group of students study regularly, the second group study occasionally, and the third group do not study. They are not studying. Now for each group I have a probability to succeed in the test, and I know how many students are in each group. So in the first group, there are 40% of the students, 35 in the second, and 25 in the third. The probability for passing a test for each group is 80% for the regular study, 50% for occasional study, and 20% for not studying. So now we can use this to calculate a probability of something, because Group A, Group B, and Group C, they are totally all the students. They are all the sample data. So if I want to calculate the probability that a student pass a test, I can define Group 1 as B1, Group 2 as B2, Group 3 as B3. Now, they are mutually exclusive, namely, a student cannot be in Group 1, study regularly, and also be in Group 2, occasional study, because he is or studying regularly or studying occasionally or not studying. It can't be in two groups at the same time. So they are mutually exclusive. Also, they cover all the possible outcomes. They are they cover all the possible way that a student be, or it is in group one or group two or group three. There are no other choice. So uh, for the theorem of total probability, those groups helps us to be the B1 until Bn we talked about. Now we want to calculate the probability that student pass the test. So we know that the probability in B1, study regularly, uh, the probability that I will get this student is 0.4, because 40% of students are in group 1, in group B1, and the probability of student being in group B2 is 35%, so this is the probability for 2, and 25% in the third group, and together they are 100% of the students. So they cover all the possible outcomes, all the possible events, or all the possible samples in the group. Also, I can define the probability of student pass the test, pass the exam, dependent on each of the group. If the student in group 1, I know that the probability that will pass is 80%. Group 2, 50%. Group 3, the probability is 20%. So now I can use the probability, the theorem of total probability, to calculate the probability of A for any student to pass the test. This is the probability using the theorem of total probability. And now we can calculate and get the result. Maybe there are calculation errors but this is the result, and you saw how we use this formula of theorem of total probability to calculate the probability of an event using a group of events which are mutually exclusive and totally exhaustive. Namely, they are uh, together they form the entire sample space and they cannot happen at the same time. That's it. This is about the theorem of total probability. If there are any corrections, please correct me. Thank for ChatGPT for making the explanation with latex. Thank you, and that's it.